Welcome. In the last session, we have seen impacts of climate change, that is the sea level rise. So now in this session, we are going to cover ocean circulation, extreme marine, weather and coupled events. So now we'll see what is the ocean circulation. So ocean circulation, when you talk about ocean circulation, you have to think that ocean currents and global conveyor belt, ocean surface and subsurface currents and a global conveyor belt. So generally, ocean current is nothing but permanent streams of water that from one place of the ocean to another place of the ocean. So generally, we call it like a it's as a ocean current, right? We have seen some here in this image the various surface currents from the western boundary and eastern boundary of the ocean currents, such as warm currents, cold currents. The combination of the currents in a loop manner, that what we call like ocean gyres and all, right? So equatorial currents we have. So this is a kind of picture where you can see all different kinds of ocean currents. So it carries a vast amount of the heat across the planet ocean. Similarly, how the atmosphere does, right? So because when there is a change in this all current existing ocean current system and the global conveyor belt, so this is a kind of another circulation. That is a one kind of large loop kind of circulation while meeting in the while runs through the three major oceans such as Indian Ocean, Pacific, Atlantic Ocean. So this is a kind of a large loop kind of global circulation. That's why we also call this circulation as thermohaline circulation. That means thermo means temperature, haline means salinity. So major driver force of this global circulation is like temperature and salinity. That's why we name it like a thermohaline circulation. The flow how it moves, based on that we also call like a global conveyor belt. You see, if it is a loop kind of global circulation while running through three major oceans, right? So what kind of changes that we can see if this current system get changed or global conveyor belt get changed in is a speed in its speed or a periodicity and all, right? So there I can say this is an example like forming of El Nino current in the Pacific Ocean because of the excess warming in the eastern and central Pacific Ocean. This is actually unusual or not a common. This is it's not a general trend. So beyond the general trend, unusually there will be a kind of during December around there will be a kind of warming of sea surface temperatures in the central or equatorial Pacific Ocean. Because of this warming, there will be another current will form, that is a El Nino event. We generally this warming phenomena we call it like El Nino. So because of this El Nino event, what will happen? There will be a lot of change in the regional current systems like Humboldt. This is a Peru current. We also call like Humboldt currents. So that will be showing us like how the changes in ocean currents impact our climate and regional climate of this marine and atmospheric as well, inland effects as well, right? If you see this El Nino event, in this case, the Peru current, because of this El Nino event, there is a change in the Peru current that are affecting the weather conditions around the world, like a severe drought conditions in the many Western countries, disaster forest, bushfires have plugged in many countries in Southeast Asia for a month, in fact, creating dangerous air pollution levels as well. And these extreme levels of flood danger announced in the two places in East Africa. So these kind of efforts that are going to be changed as the changes in as a Humboldt or Peru current changes because of this El Nino event and all. The similar kind of El Nino event was happened in 1982 and 3, climbed around 2,000 leaves and $13 billion worldwide damage. You can understand how the changes in the ocean currents can affect both marine and atmospheric impacts. I mean, as atmospheric system, whatever existing system, right? Like a kind of it can cause droughts, fires, bushfires, heavy rainfall, this kind of all impacts that we can see. And another, as I said, like of course, the thermohaline circulation. So the upper part, if you see, this is it moves from the sea surface. It can move over the sea surface also at the bottom of ocean, right? The upper part having the warm surface water. It moves that warm water to the from equator to the poles, right? If you see, the cold water runs from the cold water will be carried from the pole to equator. so from the bottom, right? So if you see this upper branch loaded with the heat moves north and delivers to the heat to the atmosphere. It carries the heat from the equator and carries to near North Atlantic and release the heat in that atmosphere, right? And it returns from the below of the sea surface around 2 to 3 kilometers below at the sea surface as a North Atlantic deep water mass, right? So what kind of impacts that we can see because of the changes in the ocean currents and all? If you see, these currents not only move the biomass but also the atmospheric weather patterns through the evaporation changes, temperature, and current direction and all, right? Because when there is a change in these currents, that can also change that can also cause a change in a concerned landforms, like because as we know already that warm currents form the grassland, because warm currents has a warm sea surface temperature, thereby you can see a lot of injection of the moisture into the atmosphere, thereby you can see the lot of precipitation and you can get the grassland nearby the land, right? In the reverse case, in the cold currents, they don't have that much temperatures to inject the I mean moisture into the atmosphere, thereby you cannot see such kind of huge rainfall, thereby you can see deserts. So like currents, how the change in currents affect in the climate change perspective, if you want to understand that, you can understand warm currents can form the grasslands, cold currents can form the deserts. So if there is a change in such currents, there definitely there will be a chance that change in these landforms as well, in a regional manner, regional scale as well. So this is one kind of effect that I can say. And of course some of the studies are saying that there are changes in I mean if there is a change in the thermohaline circulation, how it is going to be affect, that also we can see. As I said, like before, this thermohaline circulation heats the North Atlantic and Northern Europe. So if you want to understand how this thermohaline circulation keeping isolate this North Atlantic, or keeping unique in the temperatures, especially in the North Atlantic or Northern Europe, especially if you want to see, if you compare the places in Europe with locations at the similar latitude on the North American continent, the effect you can understand how this effect of thermohaline circulation while keeping the unique temperatures in this North Atlantic or Europe. If you see that comparison, Bordeaux in the Norway has average temperatures of minus 2 degrees Celsius in January, 14 degrees Celsius in July. But on the same similar another location on the same similar latitude, that is a Nome on the Pacific coast of Alaska, has the same latitude of course, has a much colder minus 15 degrees Celsius in January and 10 degrees Celsius in July. If you compare, in case of Bordeaux in Norway, minimum temperature minus 2 in January, but in case of Nome, minimum temperature minus 15 degrees. You see minus 2, minus 15. How much drastic change you can see. So because of this warming temperatures are generally due to the this thermohaline circulation, because as I said like before, thermohaline circulation carries the heat from the ocean from equator to this place in the North Atlantic or North Europe, release that heat into the atmosphere, thereby you can see this such a good temperatures in the uh, North Atlantic or North Europe, especially some locations in the Norway, compared to the some locations of the Alaska. However, the both are in the same latitude. This kind of effects also that we can see. And some of the studies are saying that regarding the Atlantic meridional overturning circulation, of course, since it is moving to the Atlantic Ocean, and it is in a meridional manner, and also overturning means it reaches the it reaches the North Atlantic as a surface current and sinks down and again returns to the equator as a bottom branch. So here it is going to be, here the overturning process is going on, that's why we call it like a Atlantic meridional overturning circulation. So some of the studies are saying like the transport of this AMOC is reduced by 5 to 48% depending on different scenarios like global warming future scenarios, right? And also saying that it is going to be significantly weakened in amplitude as well as shortened in the period under future global warming scenarios as well. And these responses could be caused by the strengthened ocean stratification, and which in turn the speed up of the baroplanic Rossby waves, because this, since it's a huge circulation and global circulation, and it runs through the three major oceans, it has a lot of connections in the holding and controlling the major circulation systems in the atmosphere as well, right? As there is a changes in the atmospheric circulations also, it can affect the changes in the this thermohaline circulation as well. So this how it is going to be impact, some of the scientific studies are saying. And of course the ocean has started to move fast over the last 30 years. Some of the studies are saying that the increased kinetic energy of the ocean currents is due to the increased surface wind spurred by the ocean temperatures, particularly around the tropics. Okay, so and if you see the another what kind of remedies that we have to do, it is necessary to fully understand to completely understand the thermohaline circulations, right? Because it's a mixed effect of many other ocean surface and bottom processes, and also it can change the overall ocean circulation and global climate as well. Because since it's a huge and global circulation, if there is some changes, we must understand in a precise manner. Otherwise, we cannot know how to respond, right? The rise of scientific studies in scientific sorry in the rise of scientific studies in the surface and lower ocean observations will improve the perceptions of the understandings of the deep ocean, because still the deep ocean is less explored to understand the dynamics or effects of the climate change on the of the ocean in all dimensions like biological, geological, and chemical perspectives, right? And of course this is a common practice that everyone we every for every impact of the climate change that we have to follow, limiting the global average temperatures to well below the 2 degrees celsius above the pre-industrial levels, according to the Paris Agreement 2015. And of course we should have some precise understanding of the ocean currents and their changes, because it's very crucial in knowing and effects of the regional climate change. That's just like I told, formation of the greenlands and grasslands and deserts and all, right? So coming to the another impact, that is the extreme marine weather and coupled events. So that are like storms. I mean tropical cyclones. Somewhere you can call it like hurricanes, typhoons, and associated heavy rains, marine heat waves, and these are the some kind of climate modes like El Nino Southern Oscillation, North Atlantic Oscillation, Pacific Decadal Oscillation, and all, right? So actually, we know that in the formation of cyclone, however, there are many factors. The surface warming, sea surface temperature, warming of the surface was a key. I can say a key to fuel the cyclones and the formation of the severe tropical cyclones. That is category number 4 and 5, right? So these severe, because as the ocean continuously warming, the formation of these severe cyclones, intense cyclone has been increasing with respect to time. So these severe cyclones and associated precipitation rates are going to be increased future to enhanced warming and cause more threat to the coastal communities as well. So an increase in the ocean temperature lead to an increase in atmospheric water vapor. Thereby you can see as more water vapor feeds to the weather system. That way there you can see the heavy extreme rainfall causing a risk of heavy rain or snow. So changes in this temperature can also change the hurricane tracks as well. Like for example, if the cyclone is going to hit some location every time usually and gives a lot of rainfall, but because of this warming patterns, the cyclone track can change and changes the precipitation pattern, and thereby you can see some places you can droughts condition there can, and some locations you can see useless precipitation over there, right? This kind of things also can happen. And ocean's average temperature has increased by 1.5 degrees Celsius in the last century, and for the past 10 years average annual ocean temperatures have been the ever highest recorded, right? So this is generally in terms of the while defining this marine heat waves, generally these are the like when the sea surface temperature has been raised than normal temperature about by 5 to 7 degrees Celsius, and if it the same temperature persists for a long time, then that kind of phenomena we can say like a marine heat wave, right? These days, and coming to this impact of climate change, especially by the ocean warming, this is the one of the most impact of this climate change, like marine heat waves, right? And as I said, like before, some kind climate modes. These are the teleconnections we can say. So this is the El Nino Southern Oscillations, North Atlantic Oscillation, Pacific Decadal Oscillations. Like these are the teleconnection. The name from the name itself, you can understand. Tele means a long distance. Connection means a kind of relation. For example, if you in case of this Pacific Ocean, so on the east side we have, for example, warm temperature, that is a low pressure. Similarly, on the sorry, west side warm temperature, low pressure. Similarly, on the east side, kind of sorry, what I can say, low temperatures, that is high pressure. So they obviously there will be a circulation in the overlying atmosphere as well as the ocean, that not in normal scenario. But if pressure changes or temperature, if the pressure systems and temperature systems get replaced, means on the west side you have a low pressure, sorry, high pressure, cold temperature. Similarly, on the east side of the Pacific Ocean, high temperatures and low pressure. The pattern, the circulation in the both atmosphere and ocean will get changed. So this kind of teleconnections that impacts also the climate. That's why we call them like a climate modes, because they has a two poles. From this you can, and these connections and the circulations, everything will get changed. That's why we name them like climate change. They happen in every major oceans, like Pacific Ocean, Atlantic Ocean, right? So basic three are the like ENSO, El Nino Southern Oscillation, and North Atlantic Ocean Oscillation, NEO, and Pacific Decadal Oscillation, PDO. So these kind of climate modes also impact yeah, gives a lot of impacts that are like extreme temperatures and precipitation, regional droughts, floods, heat waves, and cold spells. And also these extreme impacts can also agriculture, energy, forestry, and transportation as well. And also global dry changes, because dry changes in the like precipitation drought conditions. Then in general, if there is a if there is if in general condition, if some rainfall has had to come, but because of this climate modes and all, it will be replaced with drought. So drought condition will be replaced with rainfall. This kind of impacts that we have seen with some instance in this. If you see some of the what kind of impact that we have seen because of these events and all, severe tropical cyclones and associated precipitation rates are expected to increase, as I said before slide. So because of this warming and all, so these are the going to be affect a coastline in a very severe manner, like by forming the gusty wind speeds, higher storm surges, and more severe rainfall and all. And coming to the marine heat wave impacts, among the species most sensitive to the prolongated marine heat waves, that are from the basis of the most biodiverse marine ecosystem, that are like kelp forest, seagrass, meadows, and coastal reefs, right? So because the severe, most of the many severe coral bleaching events were occurred, especially in the Great Barrier Reef in Australia, 2011, 17, 19. This kind of since the last decade, many massive coral bleaching events occurred because of this excess warming and formation of this marine heat waves and all. Because but these marine heat waves not only cause this destruction of this marine ecosystem, but also it will be it is but also it is cause of the other stresses such as ocean acidification, deoxygenation, and overfishing as well, right? And also floods. Obviously floods also will be another major impact because of the heavy rainfall and all. It overwhelms the uh, drainage systems or burst river banks, and it is going to be severely affect in the heavily concentrated urban areas and cities. The effect is going to be very severe because the water cannot sink directly into the soil, so thereby you can lot of flooding event and damage to the buildings, transportation, which can very hard to be very hard, very costly to recover as well, right? So during El Nino event, I mean, so we have said generally during El Nino event, chances for we have said like there will be a drought and replacement of drought and rainfall changes. Replacement of drought will be a rainfall condition, rainfall area. Rainfall will be a drought. This kind of changes that we have talked during El Nino time. Chances for the drought increase across the India, Indonesia, Australia, and large parts of some Amazon as well. So while in the Southern Ocean, so southern United States tends to see more precipitation, right? Similarly, The reverse of the El Nino pattern is what we call like a La Nina. In this La Nina time, what will happen? Uh, Weather conditions for Indonesia, Australia, and parts of Amazon, and similarly some dry conditions in the southern tier of the United States. So, like this kind of see during El Nino time, droughts increase across the India and Indonesia, Australia, large parts of Amazon, right? But this pattern will be reversed during La Nina time in the same locations. That kind of reverse pattern during El Nino and La Nina, right? So, what kind of remedial measures that we have to do during this extreme events time and all? Of course, government must invest in a nature-based solutions alongside to control, to reduce the fossil fuel-based emissions to achieve the goals what we have set according to the Paris Agreement. And national subnational government should design and implement the measure to protect the communities and build regional ocean resilience programs and all, because we have to protect the marine protected, we have to do the marine protected areas for the species such as coral, kelp, and seagrass and all, because these all will protect us the coast, protect our coastline from the so-called extreme events, right? So, and also restrictions, and also these enforcing catch management for or fishing restriction to help limit economic losses linked to the marine heat wave uh, effects, right? And also another impact, another remedy that should follow: acceleration of urbanization, rapid development, economic structure, and global warming, which it will hiddenly increase, accelerate the dangers of the hurricane, right? So we have to deaccelerate this urbanization, rapid development of economic structure, and global warming to control or to deaccelerate the hurricane disasters, because this all process will raise the global warming. So thereby you can see the warm water more possible to fuel the more intense severe cyclones, right? We have to deaccelerate all this process, and hard and soft protection adaptations to protect our coastline from severe storms and floods and all, because we have to have some kind of adaptation methodologies to respond to the all kind of coastal flooding events or sea level rise or kind of storms and all, right? Okay, these are all some possible remedials that we have to do under these to respond or to control these extreme marine weather and coupled events as well.